Hey folks, this is Chet. So I'm going to give you some helpful hints here and take a look. Before we add fractions, we have to have a common denominator. So when in doubt, you can multiply the two together. You get a 12 and a 12. Now, ask yourself, how do I make this denominator look like this one? I need to times this by 4. 4 times 2, 8. How do I make this denominator look like this one? I need to multiply by 3. 3 times 1 is 3, and notice we get 11 twelfths. All right, great. Next page. Here you go. Multiplying fractions. When you multiply fractions, multiply straight across. All right, great. But wait a second. We could do a little bit of work right here, and we know that 3 goes into 9 3 times. Nothing else cancels. Now we can multiply straight across like this. We get a 6, and over here we just get an 11. There you go. There's your answer. All right, next problem. Slope. Slope is defined as rising over running. You know that. Well, look at my axes here. Notice my y-axis. Rising is going up and down to the blue sky. So that means that we need to have our y's on top, not x's. You put x's on top, I'm taking off full credit. This is like your third year knowing this formula, and we have to have our y's rising up and down is my y-axis. When you run across the green grass. That's my why my x's are in green. So don't forget that. Y's on top and x's on the bottom. Next thing. Here's interval notation. We have a 4, and notice it's got the parenthesis. That means this is going to be an open circle. All right, and then look at our 8 right here. Our 8 is a closed circle, so that gets filled in. This is interval notation. We need all the x's that are between 4 and an 8. So there you go. We use this a lot. Interval notation. All right, next problem. Absolute value. Now, you know that this x could be positive. That's going to be case 1. But we also know that this x might end up being negative. And that would be case 2. This is the way I teach it, and it's always case 1 is your positive case, case 2 is your negative case. Well, this is already solved. We have a 4. This one here, we're going to throw the negative on the other side by multiplying or dividing by a negative 1. And notice we get negative 4. These are both equals, so we get a solid dot at negative 4 and a solid dot at positive 4. All right, and our last problem here. Again, what's on the inside could be positive. So we're just going to write it as we see it. And now when we subtract 2, we're going to get a 3. Great. Case number 2. Now, in this case, what's on the inside could be negative. Notice I'm using parentheses. And I will allow you to throw the negative on the other side. And when you do that, folks, remember, we have to change this inequality sign right here because we just multiplied or divided by a negative, and now we get our negative 5. Here, when I subtract 2, I get negative 7. So, in both cases, there's my negative 7. Here's my positive 3. I need all the x's that are greater than that. Open circle, shaded this way. And here, x is less than negative 7. Open circle, shaded to the left. So now, when we do interval notation for this, I'm starting out with negative infinity. I'm going all the way up to a negative 7. That's open, so I use parentheses. Infinities always get parentheses. union with, we're starting at 3 and going off into positive infinity this way. So there's my infinity, and again, infinities always get parentheses. If this would have been an or equal to, then this would have been closed right here, and this would have been closed if this was or equal to. So there you go, folks. Hopefully they're helpful hints, and please start working on that packet. Thanks. Bye.